Everyone, in this video we'll discuss pushing and pulling a box at an angle. A box resting over a flat table has its weight balanced by the normal force. Thus, the net force on the box is 0. If an extra force is applied down, the normal force will increase since the table will exert a greater force on the box in order for the net force to remain 0. If an extra force is pulling the box a little bit, the normal force will decrease since the table will exert less force on the box in order for the net force to remain 0. If the force applied becomes equal or greater to the normal force, the box will be lifted off the table. If you are pushing a box over a table at an angle below the horizontal, like here, the normal force will increase by the vertical component of the force applied because you're exerting a force down, so the normal force will increase. If the mass of the box is 4 kilograms, the weight equals to 4 times 9.81 equals 39.2 newtons. So that's the weight of the box. But since the force applied is 30 newtons at an angle of 22 degrees, the normal force will be greater than the weight since there is a force pushing it down. And the normal force equation is mgf sine of theta. So 39.2 plus 30 sine of 22, which gives us 50.5 newtons, which is greater than 39.2. Notice that if the angle is 0, the normal force equals to the weight, which is the case of just pushing a box sideways. If the coefficient of friction is 0.3, then friction will be coefficient times normal force, 0.3 times 50.5, which gives us 15.2 newtons. And since the force applied has a horizontal component, the box will move forward with a net force of the horizontal component of the applied force, which is F cosine theta, minus the friction. 30 cosine of 22 minus 15.2 gives us a net force of 12.6 newtons. And here's the free body diagram of the box. If you are pulling the box at an angle, the normal force will decrease by the vertical component of the applied force. Assuming the same 4 kilogram box and the same angle, the normal force now is mg minus f sine theta, minus because you're pulling it instead of pushing it down. So normal force will be 39.2 minus 30 sine of 22 equals 28 newtons, which is less than the weight, which is 39.2. Assuming the same coefficient of friction of 0.3, the new friction is mu times normal force, 0.3 times 28, which gives us 8.4 newtons. And since the force applied has a horizontal component, the box will move forward with a net force of F cosine theta, the horizontal component of the force minus friction, 30 cosine of 22 minus 8.4, which gives you 19.4 newtons as the net force. So the box will accelerate. So here's an introduction of the equations surrounding pushing and pulling a box at an angle. Thanks for watching.